One way to treat exponents is we can think of exponents as repeated multiplication. So if we have 2 times 2, instead of writing 2 times 2, we can write 2 to the power 2. Instead of 5 times 5 times 5, if we repeatedly multiply by 5, we can use our 5 as our multiplier, and the exponent indicates the number of times we use that 5. And when we have 3 times 3 times 3 times 3, we can write that as, instead of multiplication, we can use an exponent. We can use the multiplier 3 to the power 4, which indicates we use that multiplier 4 times. And now it's important that we don't mix up our multiplication of 3's and our multiplication of 7's, because the way the exponents work is the base represents our multiplier, and if we have different multipliers, we have to have different bases, and then exponent counts that specific multiplier. Okay, so here we have 7 to the power 4. We're counting the multiplier 7 1, 2, 3, 4 times. Now, it's important to understand that exponents are not multiplication. And make sure that you're clear on this. Although we can say that when we repeatedly add, that's the same as multiplication. So multiplication can be described as repeated addition. However, we never say that multiplication and addition are the same thing. Similarly, we can say that exponents are repeated multiplication. However, we cannot say that multiplication and exponents are the same thing. They are different, and they behave differently. Just like add and multiply behave different mathematically, exponents and multiplication behave differently as well. And we cannot use exponents to express addition, subtraction. In fact, addition, subtraction, and exponents are incompatible with each other. And this is important to recognize when we talk about the math of things. We have add and subtract. The next level is times and divide. And there is a connection between add and subtract and times and divide. Okay, these things are close enough together that they're related, and we can connect them through distribution. So for example, if I have 3 times a plus 1, I can distribute to connect multiplication with addition. Exponents and roots go together, and exponents and multiplication are also connected. They are similar enough to each other, they're just one level apart, and we can connect these things together as well. So we could do multiplication with exponents, and they are compatible. And we end up with, we're able to apply exponents when there's times. Now this is an important part. We cannot connect addition, subtraction with powers. It never works. They are not related enough to be able to make them work together. It will never work. There's not one circumstance when plus and minus and powers can go together. And a good example would be this. If I have a plus b and I square it, lots of people like to say, well, this is just like distribution, it's just like powers. I can just distribute those powers and say that I can do that. This is not true. It never works. Because when I square a plus b, I get an a plus b square. I have an a plus b square. And I get 4 parts to that square. I have an a square and a b square. Well, there's a square and b square. However, notice that we're missing parts of that area. This is incomplete. A squared and b squared is not equal to a plus b squared. That's very important. Okay, and one easy way to remember that is add, subtract, powers and roots never can be applied together. They do not go together. You cannot do anything with powers and plus and minus. Okay, if you want to do something with plus and minus, you have to do it with multiplication instead of powers. So some people and this is something you run across later on, but if you have x plus 1 squared, we cannot square that. We have to do multiplication. The only way we can resolve this is if I have a plus in there, I can't do squares, I have to do multiplication. Okay, so that's a side note. The main idea then again is add and subtract, and powers and roots do not mix. So exponents cannot be used for addition and subtraction. And if I want to write this as an exponent, as long as it's all times, I can write this with an exponent. I have 1, 2, 3, 4 multipliers. So I'm going to do power 4. Here my base is 2. I have 1, 2, 3. So I'm going to use an exponent of 3 to show that I have multiplied 3 times. I have a, so my base is a. I have 1, 2, 3, 4, 5a, so I'm going to use an exponent of 5. Now, although this is all connected by multiplication, I have to count my base 5, multiplier 5 separately from my multiplier of 2. And I have to make sure that I keep my multiplication in between the two. Now that's equivalent to, some people may rewrite it like this and use the brackets to imply the multiplication between those two exponents. But we can never multiply the bases together in an exponential expression. Now here I have 1, 2, 3, 4, 5 3's, but they're not all connected by multiplication. I have to count these 3's like that. I can have 3 3's multiplied. I have 2 3's multiplied here. But since they're not connected, that's it. I have to just keep it as that plus that. And there's nothing that connects powers with pluses, so I cannot do anything about this. So what are some rules that you can state about repeated multiplication and exponents? Well, one thing is plus, minus, and powers don't mix. Okay, they just do not mix. We cannot mix powers and plus minus. With repeated multiplication, we must have the same base. Or multiplier. Okay, so those are a couple points. We cannot mix. We cannot combine different multipliers. I'm going to say bases.